Okay, Assalamualaikum and very good day, morning to everyone. Okay, so now we go to the chapter 5, which is the CPU scheduling. So previously you already learned concept of the process concept. So I hope you will understand about the understand about the process concept, because in these chapters, okay, the understanding of the process concept, you need to you have the need a basic of the um, process concept, okay, because in this chapter you will learn about the how the CPU scheduling is being conducted and how it's being done by the operating system. So CPU scheduling is the basis of the multi-program operating system. So as we know, the CPU process concept are using when you have a multi-programs, so they use a concept of context switching. So by switching the CPU among the process, the operating system can make the computer more productive. So in this chapter, you will be introduced the basic CPU scheduling concept. You already learned about the basic process scheduling concept, and present the several CPU scheduling algorithms. So we will consider problems of selecting an algorithm for the particular system. Alright, so in the basic concept, okay, so this is the outlines, okay, about the topic that you will learn for these chapters, okay, the basic concept, the scheduling criteria, the scheduling algorithm, the thread scheduling, okay, the multiprocessor, the real-time CPU scheduling, and another other examples operating system that use different times of CPU scheduling, okay. Alright. This is the objectives of this topic, okay, about the CPU schedulings, okay. Alright, so now we go to the basic concept. Okay, as we know that in the single processor system, only one process can run at one time. So any others must wait until the CPU is free and can be rescheduled. So the objective of the multi-programming actually to have more process running at all time in order to maximize the CPU utilization. So the idea is relatively simple. Okay, so the process is execute until it must wait. Okay, typically for the completions of some input output request. In the simple computer system, the CPU then just sits for idle. So all this waiting time is wasted. So no useful work is being accomplished. However, in the multi-programming, we try to use this time productively, okay, by providing the several processes are kept in the memory at one time, and when the process has to wait, the operating system will take the CPU away from the process and give the CPU to another process. And this pattern will be continued. Okay, so every time one the process has to wait, so another process can take over the use of the CPU. So therefore, the scheduling of this kind is fundamental of operating system functions. Almost all the computer resources are scheduled before it being used. So the CPU is, of course, okay, one of the primary computer resources. Thus, this scheduling is central to operating system design. Okay, so basically, why we have a CPU scheduling? Because our process system is being designed currently using a multi-program. So my means that you can have more programs running at one time. Okay, so when the CPU is because CPU you boleh manage you punya proses through the context switching, where your CPU akan boleh proses pergi from one process to another process. Okay, therefore kita boleh, therefore operating system, how the operating system manage benda ni adalah melalui scheduling. So dalam scheduling ni, operating system bertanggungjawab untuk memilih ataupun membuat selections, okay, which process need to be executed by the CPU first. So that is the responsible by the operating system lah. Okay, so therefore sebelum kita pergi lebih lanjut bagaimana scheduling dibuat, so you kena faham about certain terms di mana kita akan nampak uh, kita akan tengok bagaimana CPU has been switched from one process to another process, okay, melalui scheduling, dan kita akan nampak, okay, bagaimana dalam CPU, not only you already execute in the CPU, tetapi juga dia akan switch from the CPU to another resources lah. Okay, so bergantung kepada instruction yang diberikan lah. So in the success of the CPU scheduling, that depends on the observed property, okay, of the process. Okay, dia bergantung kepada CPU. Kejayaan CPU scheduling adalah bergantung kepada bagaimana dia observe dari segi property proses itu sendiri. The process execution consists of the cycle. Kalau kita tengok proses execution ni, okay, dia ada cycle of CPU execution. Okay, you faham the machine cycle sebelum ni kan? Okay, so bila kita buat executions, okay, dia akan melalui beberapa cycle, iaitu sama ada dalam CPU execution ataupun dia dalam input output waiting. So proses akan alternate between these two state, okay, antara CPU burst ataupun dipanggil sebagai dan input output burst. So dia akan alternate bertukar. Okay, dia bergantung kepada program ataupun proses yang running lah ketika tersebut. Okay, proses pada mulanya akan bermula dengan CPU burst. At the first time when you load the systems, okay, dia akan load instructions, whatever. So dia akan execute first your punya process. So bila you execute the process, they are in the current of the CPU burst. Okay, so during the executions, for example, they require some your program or your process requires some input output devices, so they're going to the input output burst. Okay, so input output burst. Okay, so the process are waiting for the input output burst, okay, supaya input output can operate, okay, their operations. Once they complete, so they are going back to another CPU, dia masuk balik queue, and then CPU akan execute balik. Okay, so the process is alternate, okay, antara CPU dengan input output. So the durations of the CPU burst has been measured extensively lah. Okay, although they vary greatly from a process to another process, from computer to another computer. So they tend to have a frequency curve similar. Okay, and dia ada frequency lah. Okay, yang ni kita tengok dari segi dia punya dia punya figure dia. Kalau kita tengok, the curve is generally characterized as exponential or hyper exponential with the large number of CPU burst time. Okay, banyaknya kita akan banyak on the CPU burst time, large number on the CPU burst time, and the small number of the long CPU burst times. Okay, so the input output bound program typically has many short CPU burst time. Okay, bila kita input output bound, maknanya proses awak berada di dalam input output bound, they are waiting for the input output, so they have a very short CPU burst. So the CPU bound program might have a few CPU bursts. So this distribution can be important in the selection of an accurate CPU scheduling algorithm. So which one is CPU scheduling yang sesuai kita gunakan. Alright, so dia bergantung. Okay, the other certain of the process require a longer CPU burst time, and mostly program that require for input program are very short burst time. Okay, alright. Okay, so now we go to the next part, which is the CPU scheduler. Okay, whenever the CPU become idle, okay, apabila CPU you idle, okay, idle ni mungkin disebabkan you punya proses tu sedang melakukan input output sedang execute, tengah complete dia punya task. So what happen is the CPU sementara dia menunggu input output to complete dia punya task, dia punya job, so CPU you become idle. So whenever CPU you idle, the operating system must select one of the process in the ready queue to be executed. Okay, ini ada nature, it's a big nature of the operating system. Bila dia design, dia multi program. Okay, so bila dia nampak CPU idle je, okay, bila CPU idle, sebab CPU dia tengok proses yang tengah running tu tengah input output device tengah complete dia punya task, so dia nampak CPU tak buat apa-apa, apa yang operation system akan buat, dia akan instruct the operating system instruct you punya processor, okay, untuk instruct you punya processor untuk select okay, untuk select another process yang ready dekat dalam ready queue. Okay, so you dah tahu kan process status kan, so dalam ready queue untuk dia execute. So the selection process is being carried out. Okay, so selection of the process need to be carried out by we call a scheduler. So scheduler ni dia ada dua jenis. Satu we call a CPU scheduler ataupun dikenali sebagai short term scheduler, and then this dan juga long term scheduler. Okay, kita ada long term scheduler. Okay, so the scheduler will select from a process, select a process from the processes in the memory which are ready to be execute and allocate the CPU to that process. Okay, bila dia berada dalam queue, tak semestinya dia in the first in and first out queue. Okay, dia bergantung when you are dia bergantung, tak semestinya first come first serve. Okay, kita ada beberapa various schedule algorithm nanti later on you akan belajar di mana when the ready queue can be implemented into first in and first out, can be in a priority, a tree or simple unordered linked list. Okay, conceptually, however, all the process in the ready queue are lined up waiting for a chance to run by the CPU. So the record in the queue are generally process control block of the processor lah. So semua info masih ada record lah dalam you punya process control block. So that's why the concept of process is need to come first. Okay, apa yang ada dalam proses, okay, apa yang perlu dibuat. Sebab bila dalam scheduler, all the information is being used. Okay, so where is the process need to be queued in the memory and which process, what type of scheduling algorithm that being used by each type of the process. Okay, so CPU akan buat scheduling, scheduling based on these four situation. Okay, so means that CPU scheduling may take place when the process have four situation. So when the CPU switch from running state to the waiting state, okay, when your process is switches from the running state to the waiting state, when your process is switches from the running to ready state, or when the your process switch from waiting to ready state, or the process will be terminated. Okay, for the situation 1 and 4, there is no choice in terms of scheduling. So you tak ada choice. Okay, kalau you dah terminate, you tak boleh buat apa. A new process must be selected for execution. Okay, alright. So the for situation 2 and 3, there is an options. Okay, there ada options sebab dia bergantung. Okay, running to ready state or from waiting state to the ready state. Okay, when the scheduling take place only under circumstances of 1 and 4, minimum process from the ni lah, okay. So the 1 and 4, the scheduling scheme is non-preemptive. Okay, otherwise, okay, it called a preemptive. So preemptive ni dia ada dua jenis. Okay, satu preemptive scheduling, satu lagi non-preemptive scheduling. So mana satu preemptive and non-preemptive, dia bergantung kepada situation. Okay, so the situation bila when the process switch, okay, preemptive scheduling akan berlaku when the process switch from running state to the waiting state, and when your process switch from the running state to the ready state. Okay, so preemptive scheduling akan berlaku apabila in these two situations happens. Okay, kalau dia adalah non-preemptive, okay, so ada proses tu terminate ataupun new process lah. Okay, so under the non-preemptive scheduling, apa yang berlaku ialah CPU has been allocated to the process and the process will keep the CPU until it release, okay, either terminating or switching to the waiting state. Okay, walau from the running state to the waiting state ataupun terminate, dia normally use the non-preemptive scheduling. Okay, and virtually most all the modern operating system, okay, including Windows, Mac, Linux and Unix are using a preemptive scheduling. So no longer kita dah kurang kita pakai preemptive, non-preemptive scheduling because that a lot of process running, okay, currently. So and then lagi satu kemampuan you punya processor is quite high end, and therefore they can able to do more processing, okay, during concurrently lah. Okay, proses dia punya kemampuan of processor currently much more good, performance are very good, more speed up. So dia punya proses scheduling lebih mudah lah kalau kita menggunakan preemptive scheduling. Okay, so dalam preemptive scheduling, the result in the race condition akan berlaku. Dia akan berlaku race conditions where the data or dan dia share tu among several process. Mungkin data yang digunakan tu dia akan di-share boleh several processes. So dia bergantung, dia berlaku perebutan kat situ lah, perlumbaan di situ. Which process need to use the data. Okay. So they consider the keys of the process that share the data while the process is updating the data and it's being preempted so that the second process can run. So the second process try to read the data. So which means that they have an inconsistent state. So apa yang berlaku ialah, okay, apa beza preemptive scheduling dengan non-preemptive kita dah tahu. Okay, bila berlaku dia. Preemptive scheduling ni di mana ialah di mana proses, okay, akan bila preemptive scheduling, okay, the process will be forcible yield the processor. Okay, bila dia berlaku je preemptive scheduling, okay, jenis preemptive scheduling ni, okay, dia akan forcible the process, okay, to give the CPU. Okay, alright. Kalau non-preemptive, okay, dia akan voluntarily yields the CPU. Okay, maknanya dia akan release, okay, dia secara volunteer akan release the processor. Okay, sebab processor yang pegang the process. Okay, jadi kalau beza dia antara preemptive scheduling dengan non-preemptive scheduling ialah kalau non-preemptive scheduling, okay, dia akan voluntary, processor akan proses akan secara volunteer release the CPU. Kalau preemptive scheduling, okay, the preemptive scheduling, the process will forcibly use the CPU because of the certain situation lah, okay, yang tadilah, okay, alright, bila preemptive and non-preemptive scheduling. Okay, so apa yang menjadi isu di dalam preemptive scheduling ialah berlaku race condition. So race condition ini hanya bila when you have a data set. Okay, sebab you run several processes running at the same time in the preemptive scheduling, and then apa yang berlaku ialah you use the same data untuk a several process. So bila you run the same data, so dia akan berlaku perlumbaan dekat situ. We have what we call the race conditions. So the race conditions happens, okay, when you have a two process are sharing the data. Two or more process are sharing the same data. For example, if one process tengah update dia punya data, and then is a preempted. Okay, dia terpaksa force the CPU, dia terpaksa release the processor untuk pergi ke the next process. So apa yang berlaku ialah second process pula bergantung kepada data yang dia share sebelum ni. Jadi maka ia menyebabkan the second process receive the inconsistent data state. Okay, so ini berlaku. So that's why this issue will be tried to be solved, okay, in the chapter 6 nanti, which is we call a process synchronization. How you synchronize the process, especially you have a multi-process running at the same time. Okay, so kita akan tengok later on the process synchronization. So now we going to focus more on the preemptive scheduling. Alright, so in the okay, so another component that involved in the CPU scheduling function is the dispatcher. Okay, this dispatcher is actually a module di mana dia akan control CPU to the process selected by the short-term scheduler. And this function involve two. Dia involve, okay, dia involve some other switching context, okay, switching to user mode or jumping to the proper location in the user program to restart the program. Okay, so dispatcher ni adalah modul di mana kita akan give control of the CPU, processor, operating system akan give control of the CPU bila you have been selected untuk short-term scheduler. Okay, so this function ni berfungsi untuk switch the context from one process to another process, okay, or switch from the user mode to the kernel mode, okay, or you jump to the another proper locations, okay, to restart the program. Okay, so the dispatcher should be as fast as possible. Kadang-kadang kita tak perasan benda ni kerana dia switch very fast because your CPU, your processor is very fast buat execution. So you doesn't realize or notice, okay, benda ni berlaku, okay, whenever the process is being switched. So the time it takes for the dispatcher to stop one process and start another running is known as a dispatch latency. Alright, dispatch latency ni dia masa, okay, masa dia nak ambil untuk dia switch dia nak stop one process and start the new another process to be running, dia panggil sebagai dispatch latency. Okay. Okay. Alright, so before we go to the further detail on the CPU scheduling algorithm, we have to know the terms or what are the criteria of CPU scheduling need to be used. Okay, the first thing is about the CPU utilizations. Okay, the CPU utilization is we want to keep the CPU as busy as possible. Okay, so because why? Because operating system is being designed is to maximize the CPU utilization. So therefore, the operating system akan keep on looking at the CPU status, okay, whether the CPU is busy or not. Okay, so if your CPU is idle, then give a process, okay, to the CPU to execute. Okay, so CPU utilizations. Okay, that's why they can keep the CPU as much busy as much possible. And then we have a throughput. Throughput is where if the busy executing process, then work being done. So they measure the numbers of process that being completed per time unit. Throughput is the how many numbers of process that can be completed at the time given. Okay, for how long the process can be executed. Okay, per hours, for example, or for the short transactions. Okay, so it can be maybe at 10 seconds, it can be in the split seconds. Okay, it depends. Okay, and then we have a turnaround time. Turnaround time is the amount of time to be executed at the particular process. Okay, from the point of view of particular process, the important criteria is how long it takes to be execute the process. Okay, ada beza throughput dengan turnaround time. Throughput adalah berapa banyak proses yang boleh execute and it can be completed dalam masa tertentu. Turnaround time adalah how long. There is more towards the numbers, is a time. It's most based on a time, how long it can be execute to that process. Okay, alright. Okay, so the turnaround time is the sum of the period that spent waiting to get into the memory, waiting to the ready queue, execute on the CPU, and also doing their punya input outputs. Okay, so another one is the waiting time. So the waiting time basically is the CPU scheduling algorithm, which does not affect the amount of time during the process execute or does uh, okay, executes orders input outputs, and it affect only the amount of time that process spend waiting in the ready queue. So waiting time ni adalah mana bila kita buat search scheduling algorithm, okay, does not affect berapa banyak amount of time yang dia perlu execute. Tidak. Okay, dia akan hanya effect bila uh, bila berapa masa yang dia ambil untuk proses to spend untuk waiting, okay, dalam ready queue so that dia boleh start dia punya execution lah. Okay, nanti you akan kira benda ni nanti dalam step scheduling algorithm lah. And then kita ada response time. Okay, oleh kerana kita punya sistem ni more interactive, turnaround time may not be the best criterion. Okay, so therefore kita ada satu lagi kriteria di mana when process can produce some output fairly early and can continue computing the new result while previous result, okay, are being output to the user. So another measure of the time is the summation of the request until the first response is being produced. So this is we call as a response time. Basically, the response time is the amount of time it takes when the request is submitted until the first response is being produced. Okay, so ada beza antara waiting time dengan response time. Okay, alright, turnaround time berbeza. Alright. It is desirable to maximize the CPU utilization and throughput and also to minimize the turnaround time. Okay, waiting time and response time. In the most cases, we optimize the average measures. Okay, kita biasanya kita akan measure dia punya average. Okay, average ni berapa banyak turnaround time bahagi dengan dia punya berapa banyak proses yang ada lah. However, under some circumstances, okay, it is desirable to optimize the minimum or maximum value rather than the average. For example, to guarantee that all the users get the good services, we may want to minimize the maximum response time. Okay. So investigators have suggested that for interactive system, untuk interactive system, it's more important to minimize the variance in the response time than to minimize the average response time. So a system with a reasonable and predictable response time may be considered more desirable than a system that uses faster on the average but is highly variable. So however, the little work has been done on CPU scheduling algorithm that minimize the variance. So as we discussed, the CPU scheduling algorithm is the following section will be illustrate dia punya operation lah. So later on kita akan tengok bagaimana scheduling algorithm, pemilihan scheduling algorithm adalah bergantung kepada maximum, how you maximize the CPU utilization, how you maximize algorithm tu boleh maximize the throughput atau tidak, okay, berapa minimum turnaround time dia, okay, melalui average dia lah, minimum the waiting time and the minimum dia punya response time. The scheduling algorithm, it depends on this. Okay, so that's all for the introductions of the CPU scheduling algorithm. So the next you akan diajar in the several types of CPU scheduling algorithm and how you calculate it. Okay, thank you.